Welcome to the My Screen Grabber tutorial. In this guide, you'll learn how to build a sleek and practical Python application using the PySide6 framework to capture screenshots from any monitor connected to your computer. To get started, make sure you have Python installed from python.org. And PyCharm, the IDE we'll use for development, from jetbrains.com/pycharm. After installing both, open PyCharm and click New Project to begin setting up your workspace. Name this new project as My Screen Grabber. Verify that the correct Python interpreter is selected in the Python version field to ensure PyCharm uses your installed Python environment. Then click the Create button to generate your new project. Next, create your first Python file to hold the code for the main application window. Right-click the project folder in PyCharm to begin. Point to New. Select Python file. Name the new Python file main window. PyCharm will automatically add the .py extension, then press Enter to create it. Here is the workspace where we will implement the main window of our application. Note that this is where all the visual and functional components of the window will be defined. The entire code required for this project has been pasted, but do not worry, it will be reviewed line by line to explain each part in detail. Before proceeding, install the missing Python libraries indicated by the IDE. Hover the mouse over the word PySide6 to view the quick fix option for installing it. When the unresolved reference message appears, click on the Install Package PySide6 option. If the confirmation dialog box appears, select the Don't Ask Again checkbox. Click on Yes. Notice that Capture Overlay is still marked as a missing package or module. This happens because the file has not been created yet. Capture Overlay is not a built-in Python library but a custom Python file that will be created later to contain the main functionality of this application. Create the Capture Overlay file by right-clicking on the project folder. Point to New and click on Python file. Name the new file Capture Overlay and press Enter. This is another empty workspace ready for implementation. This is where the core functionalities of the application will be developed. The entire code has been pasted at once, but it will be reviewed line by line. The first 3 lines import essential PySide6 modules used for the application interface. Qt and Qrect from PySide6.qt provide constants and rectangular geometry handling. QPainter and QColor from PySide6.qt allow drawing and color operations. QWidget from PySide6.qt widgets defines the base class for creating custom interface elements. This line defines a new class named Capture Overlay that inherits from QWidget. It represents a transparent overlay window that covers a screen, allowing the user to select an area for capturing. All drawing, mouse tracking, and interaction for the selection process are handled inside this class. This code initializes the Capture Overlay window. It first calls the QWidget constructor with super ***init***. It stores a reference to the main window to communicate selection data. The window is made frameless, always on top, and treated as a tool window so it does not appear in the taskbar. The background is set to be transparent, the cursor changes to a crosshair for selection, and mouse tracking is enabled so movement is detected even when no buttons are pressed. The paint event function is responsible for visually rendering the overlay each time the window updates. When called, it uses a QPainter to draw a semi-transparent dark layer over the entire screen, creating a dimmed effect. If a selection is active, it calculates which portion of the selected rectangle overlaps with the current screen and clears that area, revealing the desktop beneath. In short, this method handles the live visual feedback during the selection process, showing both the darkened background and the transparent selection area. This line of code grabs from the window passed to the constructor of the Capture Overlay class to determine what is the current selection state. The selection state is an object that contains the following properties. Begin, which defines the beginning position of the selection, End, which defines the ending position of the selection, and mostly important active, which is a boolean that determines if the user is currently selecting or not. The begin and end properties are now just placeholder for future implementation. For now, we only care about the active property. If the selection state is not active, that means the selection of the area of the screen the user wants to capture has not started yet. And if so, we want to dim the entire screen so the marquee selection can be obvious, indicating what the user wants to grab. That line builds a rectangular selection area from two screen points. State, begin, is where the mouse was first pressed, and state, end, is the current or final mouse position. QRect, state, begin, state, end, normalized, constructs a QRect using those 2 points and normalizes it so that its width and height are always positive, regardless of drag direction. In effect, it defines the precise region of the screen the user has selected for capture. That code limits the visible selection area to the portion of the user's drawn rectangle that lies within a given screen overlay. Intersected, self.geometry, computes the overlap between the global selection rectangle and this overlay screen region, discarding any part outside the monitor. Then translate, self.geometry, top left, converts that intersection from global screen coordinates into the overlay's local coordinate system so the overlay can accurately render only its portion of the highlighted selection. This code handles the visual effect of highlighting the user's selection. It creates a QPainter tied to the overlay widget, then fills the entire screen area with a semi-transparent black color, RGBA 000128, to dim everything. If there is a valid selection, local_reveal_rect not empty, it switches the painter's composition mode to composition mode_clear, which erases pixels instead of painting them. Finally, it fills that rectangular region with transparency, visually cutting out the selection area and revealing the screen beneath. This method starts the selection process when the user presses the mouse button. It marks the selection as active, records the click position and screen coordinates as both the starting, begin, and current, end, points, and then calls update_all_overlays on the main window so every screen overlay refreshes to show the initial selection state. This method updates the selection area as the user drags the mouse. While the selection is active, it continuously records the mouse's current global position as the new endpoint, then triggers update_all_overlays, so all overlays redraw the updated rectangle in real time. This method finalizes the selection when the mouse button is released. It simply calls finish_capture on the main window, which ends the selection mode, closes all overlay windows, and proceeds to capture the selected screen area as an image. Okay, that is it. This is all we need inside the Capture Overlay Python file. Now, let's go ahead and click to return to the main window Python Files tab. Notice now that the wiggly line is no longer appearing under the name Capture Overlay, because we just finished its implementation and now it can import it into the main window file. Class main window, QMain window defines the main application window that manages user interaction, toolbars, and the image capture workflow. It inherits from QMain window, gaining standard window features such as a title bar, menus, toolbars, and a central widget. In this project, it initializes the toolbar buttons, capture and save, holds the current image display, QLabel, manages multiple full-screen overlays for multi-monitor capture, and coordinates the capture, saving, and reloading of screenshots across the app's lifecycle. This constructor initializes the main window. It first calls super__init__ to run the base QMain window initialization, ensuring the core window setup and event system are ready before adding toolbars, widgets, or custom logic specific to this app. These lines set up the initial state of the main window. Self.capture_overlays stores all overlay windows, one per monitor, used during screen capture. Self.selection_state tracks whether the user is selecting an area and stores the start and end points. Set window title, image viewer, assigns the window title, and set geometry, 100, 100, 600, 500, defines its initial position and size on the screen. These lines create the Windows toolbar interface. QToolbar, main toolbar, constructs a toolbar labeled main toolbar, and add toolbar, qt.top toolbar area, toolbar, attaches it to the top area of the main window, ready to hold action buttons like capture and save. This code adds the capture button to the toolbar. QAction, capture, self, creates the button labeled capture. Its triggered signal is connected to the method on_capture_clicked, which starts the screenshot process when clicked. Finally, toolbar.addAction, capture_action, inserts the action into the toolbar for user interaction. This code adds the Save button to the toolbar. HuAction, Save, Self, creates a toolbar action labeled Save. When clicked, it triggers the on_save_clicked method to save the currently displayed image. Toolbar.addAction, Save_action, places the button on the toolbar next to other actions like capture. These lines define the main image display area. HuLabel creates a label widget that will hold and show images. SetAlignment, HuT.AlignCenter, centers the image within the label. SetCentral widget, self.label, assigns the label as the main content of the window, making it occupy the full available area. This loads and displays the initial image. HuPixMap, animeimage.jpg, reads an image file into memory for display. _update_scaled_pixmap, scales that image to fit the window while preserving its aspect ratio and updates the label with the resized version. This method ensures the displayed image resizes smoothly with the window. Whenever the window size changes, _update_scaled_pixmap, rescales the image to fit the new dimensions, keeping its aspect ratio. Super.resizeEvent, then calls the base class implementation to preserve normal resize behavior. This helper method refreshes the displayed image to fit the window. If there is a valid original_pixmap, it retrieves the available display size and scales the image to fit while maintaining aspect ratio, qt.keepAspectRatio, and smooth quality, qt.smoothTransformation. The scaled result is then set on the central label for display. This method initiates the screen capture process. It first minimizes the main window to keep it out of the screenshot. Then it resets selection_state to prepare for a new selection. For each connected monitor, it creates a capture overlay window that covers that screen, shows it, and stores a reference in capture_overlays. These overlays allow the user to draw a rectangular capture area across one or multiple monitors. This method refreshes every overlay window. It loops through all active overlays and calls update on each, triggering their paint event to redraw the current selection area in real time. This method finalizes the capture after the user releases the mouse. If a selection was active, it deactivates it and builds a normalized QRect from the start and end points to define the capture region. It then closes all overlay windows and clears their list. Finally, it schedules a short delay, 100 milliseconds, before calling take_final_screenshot, rect, allowing overlays to close before the screenshot is taken. This method performs the actual image capture. It receives the selected screen region, rect, determines which monitor it belongs to, calculates scaling for high DPI displays, and copies that region from a full screen grab. It then autosaves the cropped image to a timestamped PNG in the saved images folder, updates the clipboard and viewer with the new capture, and restores the window to normal view. This guard clause cancels invalid captures. If the selected rectangle is too small, less than 2 pixels wide or tall, it skips capturing. It restores the main window to its normal state and reactivates it for user focus, then exits the method early. These lines identify which monitor the capture area belongs to and prepare scaling data. Screen@, rect.top left, finds the screen under the selection starting point. If none, it defaults to the primary display. Device pixel ratio retrieves the scaling factor for high DPI screens, and geometry gives the screen's position and size in global coordinates. This code converts the global selection rectangle into screen relative pixel coordinates. It subtracts the screen's top left position to get local offsets, then multiplies by the device pixel ratio, DPR, to account for high DPI scaling. The resulting crop_rect precisely defines the capture region within the raw screenshot image. These lines perform the actual capture and cropping. Screen.grabWindow, 0, takes a full screenshot of the entire screen. Copy, crop_rect, extracts only the portion defined by crop_rect, producing final_pixmap, the final captured image ready to be saved and displayed. This block automatically saves each captured image. It builds a saved images directory inside the apps folder if it doesn't exist, generates a timestamp-based file name like capture_20251029_1555512.png, and writes the image to disk in PNG format. The os.makers, exist_ok equals true, call ensures the directory is created once without raising errors if it already exists. This block updates the app state after capturing the screenshot. It copies the final image to the system clipboard, assigns it to original_pixmap for viewing, and rescales it for display using _update_scaled_pixmap. Finally, it restores the window to normal mode and brings it to the foreground so the user can immediately see the captured image. This method reloads an image from the clipboard into the viewer. It gets the system clipboard, checks if it contains a valid image, converts that image to a QPixmap, stores it as original_pixmap, and rescales it to fit the display using _update_scaled_pixmap. This method handles the capture button click. When triggered, it simply calls capture_screenshot to start the screen capture process across all monitors. This method runs when the save button is clicked. It checks if there is a valid image to save. If not, it warns the user. If an image exists, it ensures the saved images folder exists, generates a timestamped file name like manual_save_20251029_1555600.png, and saves the current image as a PNG. After saving, it shows a confirmation dialog on success or an error dialog if the operation fails. This block starts the application. It creates a QApplication instance, instantiates main window, and displays it on screen. AppExec launches the Qt event loop, keeping the app responsive until it's closed, and sys.exit ensures a clean program termination when the window closes. Now let's take our new app for a spin. To run the app, right-click anywhere inside the __main___ block. Click on the Run option. Click on the Capture button. And make a marquee selection. Once you release the mouse, you will see the captured selection. If you open the saved images folder inside your project directory, you'll see that the captured screenshot has been automatically saved as a PNG file, complete with a timestamped name for easy organization. In this tutorial, you learned how to build a complete screen capture application using PySide6. You implemented a main window with toolbar buttons for capture and save. Overlay windows that allow users to draw a selection area across multiple monitors. Logic to grab, crop, and scale screenshots while maintaining aspect ratio. Automatic and manual saving of captured images as PNG files. Congratulations, you've created a fully functional multi-monitor screen grabber that combines GUI interaction, image handling, and file management.